Covered arrays. Your learning target today is I can use the area model to decompose arrays into smaller problems. And you'll know you're successful when you can break down a covered array by finding smaller multiplication problems within the array. Our first vocabulary word for today is one that we kind of saw yesterday, but today I'm going to give you the word for it, and it's the word horizontal. And a horizontal is a type of line that goes from left to right. So if you want to think of the array, which you will see in a little while, a horizontal line would be the number of dots that are in each row in the array. And then the next word is vertical, and that's the opposite. That's a line that goes not from left to right, but up and down. And when you think of the array, it's the number of dots in a column. Remember the dots that go up and down? I've called it a column. That's a vertical line. And the last one is relationship. So you know kind of what that means, like when we talk about relationships and other things. But a relationship today that we're talking about are how problems are similar and connected to each other, or how problems are related. So you know that when we use the distributive property and I decompose problems, just like when we do an array too, I have the problem 7 times 8. And I know that some related problems to that, problems that are in a relationship with 7 times 8, would be 5 times 8 and 2 times 8. Because all of their factors are 8. And I know that 5 and 2 make 7. So when I break down 7 times 8 into those two problems, I can figure out 40, because that's 5 times 8, plus 16, because that was 2 times 8, equals 56, which we know is the answer also to 7 times 8. So there's a relationship among all of these multiplication problems that we are going to solve today, and I want you to recognize that because that will help you in breaking apart your covered array. So we're going to be practicing covered arrays again today, and I am not going to give you the full array. Remember, it's your job to try to figure out what is missing in this array. And by doing that, we look at the horizontal line, right? That's horizontal. And then we look at the vertical line. Remember, horizontal is from left to right. Vertical is up and down. And a way I like to kind of remember that is if I'm looking out at the horizon, like if this was the lake and this is the sun setting, this is the horizon. That straight line that goes from left to right. So that's how I remember horizontal, is by thinking of horizon. And this is the horizon, the straight line. So that's my little way of remembering. But let's look at this array. We're looking at the pink horizontal line and the blue vertical line. And remember, the vertical line is the column. So that's why we know that's vertical. And this is the number of dots in each row, and we know that's horizontal. So let's look at how many dots we have. We have 5 on top, right? That's what I circled in pink. So we know we have 5 times what? What's in blue? What's in our vertical line? 1, 2, 3, 4, 5, 6, 7. So we have the problem 5 times 7. We don't need to fill out the rest of the array because we know, as long as we know our horizontal line and our vertical line, we don't need to know anything else. So 5 times 7. How can we break that apart by using the area model? I know that I have 5 on the top and I have 3 on the side. Whoops. And so I know 3 times 5. That problem is related to 5 times 7. There's a relationship there. So by doing that, the 5 stays the same, but we have 5 times 3, which means those 5s are making sure that this problem is related to each other. And that 7 we had split into a 3 and then something else, right? 5 times 3, I know that one really easily. That's 15, right? Well, what else can we do to break this problem apart? By finding the relationship between the 5's. Okay, what other times 5 problem do I know? I know 5 times 2. That's another one that I know really well. So 5 times 3, which we know is 15, plus 5 times 2, that's 10. And then what do we have left over? Oh, I see another 5 times 2, another part of that relationship. So 5 times 2, again, is 10. So we have 15 plus 10 plus 10. What does that give us? Well, 10 plus 10 is 20, and we have 15 left over. That makes 35 total. So 5 times 7 equals 35. Or we know that there's a relationship between 5 times 7 and what other problem? 7 times 5. They're both 35. Let's try some. So with this next one, remember, let's look at the horizontal line and the vertical line. And let me use a different color for the vertical line. Sorry about that. All right. So dark blue for the horizontal line. How many dots do I have in the horizontal line? I have 9, right? So I have 9 times whatever's in my vertical line or my column. And I have, it looks like 3 and 3, 6. So that's 9 times 6. So again, let's find out what to do figuring out this covered array. And I'm going to find the relationship between 9 times 6 and a smaller problem by breaking it down. But you might already know 9 times 6, and that's great if you do. But please watch to make sure that you understand how I can break this down and make it more doable if you were stuck. So I have 9, and I see a problem that I know really well. And that's 9 times 4, right? Because there's 4 on the side times 9 at the top. So 4 times 9, I know that that's 36. So I'm going to keep my 9 the same, but we had split the 6, obviously, into a 4 and then something else. And that leaves me with only 2 left in our column or our vertical line. 2 times what? 9. Our horizontal line stays the same. So what is 2 times 9? That is 18. So a 9 times 2 or 2 times 9 is what was left over. And we can add 36 plus 18 to figure out the answer to 9 times 6, the product. So we have to do 6 plus 8, and that is 14. And then 30 plus 10, which is 40. What would be 40 plus 14? Can you help me out with that? 40 plus 14. Thank you. That's 54. Thank you very much. Good job. So 9 times 6 equals 54. Or what's the other related problem? 6 times 9 equals 54. Thank you. Good job. All right, this is the time where after I read you the problem, I will want you to try this on your own and pause the video. So I actually am not going to tell you the problem this time. I want you to figure this out. What multiplication does this covered array represent? And then how can you figure this out? You might have to break it down like I've been showing you. You might not have to. But please try to practice this. And it would really be awesome if you do already know this problem to try to challenge yourself and figure it out by doing the area model. which is what I've been showing you, right? By breaking it down. So if you already know this answer right away, figure it out both ways then, because I should have the area model be at least one of those strategies. All right, please pause the video and good luck. Okay, so by now you should have solved the problem, and I hope that you remembered to look at your horizontal line and your vertical line. Your horizontal line you should have came up with that you have 8, right? And then if you counted your vertical line, you had 9 going down. So this problem represented what multiplication equation? 8 times 9, or 9 times 8, right? Okay, so by doing that, I really hope that you did the area model to figure this out. And if you already knew the problem, 8 times 9, if you already knew the answer, that's great. But also, I wanted you to try the area model, remember? So then you could have broken this problem apart differently. Now, I'm going to break it apart one way, and it might be the same as you, or it might be different. As long as you come up with the same product, it does not matter how you broke this apart. But this is one way you could have done it. So I saw the problem 8 times 4. And 8 times 4 is 32. And then I saw 8 times 3. And 8 times 3 is 24. And then I saw an 8 times 2. And that is what? Oh, thank you, 16. Okay, so that's how I broke my problem apart. And I'm going to have to do some erasing right here to rewrite what I had. Okay, let me rewrite my 24. Thank you for being patient with me. Okay, so I have, let's see what we did first. We did 8 times 4 plus 8 times 3 plus 8 times 2. And that is, those 8s are staying consistent, right? Because we know that all these problems have a relationship with 8 times 9. The 8 stayed the same. The 9 was split into this 4, 3, and 2. We know that all those numbers combined make 9. So 8 times 4 was 32 plus 24 because of 8 times 3 plus 16 because that was 8 times 2. And then I add them together. For 32 plus 24, let's figure that out. First, you should get 56 plus 16 because that was what was left over. Okay, 6 plus 6 is 12, and 50 plus 10 is 60. Okay, so 60 plus 12 gets us our final product of 72. So you should have gotten 8 times 9 equals 72, or 9 times 8 equals 72. You could have broken that apart differently than me, or the same. Great job. Thank you for trying this with me today. So remember, your learning target today is I can use the area model to decompose arrays into smaller problems. And you'll know you're successful today when you can break down a covered array by finding smaller multiplication problems within the array.